Morning, good afternoon, good evening, wherever you are, or if you happen to be catching this on replay. My name is Aaron Delp. I'm a solutions architect here at SolidFire, and I'm joined in the room by Rob Gordon, solutions architect, and Josh Etwell, solutions architect as well. And we wanted to talk to you a little bit today about VMware and SolidFire and some of the benefits of this solution, as well as some of the issues we see in VMware and virtualized environments today, and how do we deliver predictable application performance, and at the same time, when we're consolidating workloads, how do we improve that infrastructure efficiency, if you will. And so with that, I want to briefly go over the agenda. We're going to do an intro to SolidFire, a very short version. This is not going to be an entire presentation on SolidFire and the storage. We're just going to give you enough of an introduction to really understand where we're coming from, and then really dig into VMware problems that we're seeing. And that leads us to the first one, which is this consolidation of multiple mission-critical applications. What does that mean, and how do we achieve that? And then next we're going to go into integrated end-to-end quality of service. How do you deliver predictable performance to the storage subsystem as well as a VMware virtualized environment? How do you combine VMware SIOC and SolidFire QoS? And that's something we're going to show you, and we're going to show you a demo of that as well. And then lastly, we're going to talk about efficiency. If we're doing a lot of consolidation, some issues can lead. You can get VMware sprawl. You can get kind of wasted resources, if you will. That tends to happen. Well, how do we handle all of that? Something we want to specifically talk about as well. And so with that, I'm going to jump into the first kind of topic here, which is this introduction to SolidFire, the short version. And what is SolidFire? Well, scale out high performance all flash for large-scale infrastructure. And think of it this way, it's very scalable. You can start out at a minimum of 4 to 5 nodes and scale up as high as 100 nodes. And as you have a need for more capacity or more performance, you simply add nodes to the system. It is both 10 gig iSCSI as well as fiber channel, and delivers much more performance in the same footprint than a traditional SAN would. But at the same time, really has a very feature complete, especially for the enterprise, feature set, really of any AFA or all-flash array that's out there. And so how do we deliver replication, cloning, snapshots, deduplication, thin provisioning, encryption, all of these things we've come to expect from storage systems in the industry. And at the same time, how do we deliver that in an efficient manner that can be delivered less than $3 per gig? Well, this was all basically started to really solve some problems, right? Enterprise IT really kind of lacked storage agility, and that created some problems with traditional enterprises. Enterprises, they really are facing competition of how do you deploy new applications? How do you go faster? If you're going to fail, you want to fail as fast as possible these days. And how do you use that agility as an advantage? How do you provide scalability to your infrastructure? How are you able to really take your infrastructure and create dynamic pools of resources to host multiple applications? And what we've found is other all-flash arrays tend to only solve for one of these features, performance. But they also tend to solve for performance but not have predictability. It is basically a dragster. It goes really, really fast. But at the same time, how are we going to guarantee multiple applications together? And as well as all of these other features, and that's where SolidFire comes into play. Purpose-built to not just go fast. Purpose-built to really be able to deploy multiple applications in a way that is both agile and dynamic with predictable performance and a very efficient manner and in a very automated manner. And so we start to look at the architecture. Excuse me one second. I apologize, everybody. I'm recovering from being sick, and I'm kind of losing my voice, so I have to drink every now and then, so I apologize. One second. So what do we mean by a scale-out architecture? Again, this is kind of a starter node, if you will. It's the nodes in black on the left. In this one, we started out with 5 of our what we call 90-10 nodes. And then if you add more capacity or performance, we add another node. In this instance, the next one up is gray. Or we could add another one after that, orange. And what's really nice about this is you can add them at any time. No downtime in the addition of nodes. Very flexible addition. And what is also very unique in the industry, you can remove nodes. We actually have a number of customers that have multiple arrays and multiple locations, so geographic dispersion, if you will. And they might have one array that has some extra capacity. You can actually take an array out of a cluster seamlessly with no downtime, put it in a FedEx box, ship it somewhere else, and add it to another cluster. We have a number of customers that are almost doing manual load balancing in the field, if you will, because this is something that is truly unique of adding and removing nodes with no downtime. And so, in addition to that, we have the idea of where do we sit in the market. On the bottom in the orange is kind of the more traditional disk-based vendors that are out there. And on the left-hand side in gray are some of the new AFAs, or all-flash arrays, that are there. And you'll notice the orange, it is very much, maybe not as high performance, but certainly providing a lot of capacity. And then on the gray, really a lot of go really fast, but not necessarily scaling out or having a lot of capacity, just a lot of performance. And you'll notice the SolidFire solution, we have three models. And think of it this way. The one node is heavier on capacity, one of them is heavier on performance, and one of them is kind of the Goldilocks. It's just right. It's right in the middle, right? And so what we are able to do here is really mix and match nodes to create a range that we feel from both a performance and capacity standpoint, we're untouched in the industry right now. And remember, again, it's not just about performance and capacity. Not all flash arrays are created equally. We have a very unique design in the fact that we check those first couple boxes there, but we go on, and shared nothing high availability allows us to scale much further than most of our competitors, scaling beyond 100 terabytes, guaranteeing performance to all of these workloads, because the larger you get and the more applications you're going to put on this, obviously you need predictable performance. And the more workloads that are there, you need to automate this as well. And we feel like we're in a very unique position of really the next generation data center providing that foundation that is necessary. And that's the short introduction. With that, I apologize, I haven't been watching the chat. Any outstanding questions we need to look at there? Okay. Just going to say, I'll answer one of them just so in case you can't see the chat and you're on replay later. It was asked, what is the minimum number of nodes? The minimum number of nodes is 4 nodes. We recommend 5 nodes as the minimum, but the minimum number that you can do is 4. And think of that from a failure scenario standpoint. If one of them fails, you're down to 3. One of them fails, you go from 5 to 4. It's basically, if one fails, how much recovery do you have within the pool of resources? Any other questions I need to talk about very quickly? All right. Cool. So we're going to move on to the next section, workload consolidation. And so we've moved beyond the hardware introduction and really talking about how do we start to combine, either in a virtualized environment or a non-virtualized environment, how do you put tens, hundreds, thousands of applications on the same system? And how do you do that if those are mission-critical systems? Well, we feel our foundation and where we came from, our roots, are very different in the fact that we really are trying to solve for a problem of multi-tenancy. And multi-tenancy, our founder actually comes from a very large service provider. And in handling a bunch of different tenants and applications at a service provider, you never quite know who's going to do what when. You have no control over those tenants. And so at any given time, you might end up with exactly what you see here of a noisy neighbor. And traditional multi-tenant, they weren't able to deal with this very well. And so it was almost an honor system of you really hoped that all of your neighbors were working well and no one was going to impact you at any given time. And this became an issue. And the more applications and the more tenants, obviously the bigger chance you have that this will happen. And when we're talking about systems that scale and that we're actually talking about combining mission-critical applications, this is something we have to prevent. And so what we've done is want to focus on multi-tenancy here of you can set up performance tiers or quality of service through SolidFire. And actually this is an actual service provider. This is their data of we actually had had a noisy neighbor and it was impacting the performance of the system. And then you will see we set up all of the performance tiers and SLAs, and then we kind of hit enable on all of them. And we set up 4 performance tiers on the right-hand side there, 0, 1, 2, and 3, and everyone kind of auto-balanced, if you will, into their appropriate SLA buckets. And so by doing this, we're giving those noisy neighbors the performance they need, and at the same time guaranteeing performance to everyone else all at the same time. And how do we go about doing something like that? Well, I'm going to explain this here, and actually the box on the right is straight out of our user interface, but I'm going to go in depth in the next section and the demo of our VMware, vSphere, and vCenter plugin. You can actually control all of this from vSphere, and that's something we're going to talk about and go in depth in a little bit. But I want to explain the concepts. First of all, we have the idea of performance virtualization, and we're very unique in this respect because most of the arrays that are out there, all flash or not, have done capacity virtualization, meaning they've taken all of the drives in the system, whether they're flash or not, combined them all, and presented large pools of capacity. And storage administrators traditionally have, I need this level of capacity, or I may need a level of performance and I need to touch a certain amount of drives to get a certain level of performance. Well, what we've actually done is we've virtualized both capacity and performance so that when you actually create a volume or create a LUN, what you're actually doing is you're not just assigning capacity and space, you're also using the performance aspects of it as well. So I'm going to give it a minimum amount of IOPS, a maximum amount of IOPS, and some burst as well in case I do need to go beyond that maximum for a short period of time. And then also the idea of there's an account. And I apologize, it's hard to read, but on the right-hand side, the second one down is an account. And that is the multi-tenancy aspect of this. That account could be an organization, it could be a tenant, it could be an application, it could be production, it could be dev. However you want to really assign these tenants. So you're giving it performance, you're giving it capacity, and you're giving it tenancy all in one. So we're really bringing all of these design aspects together when you create a volume and present it out. And because of that, again, virtualized or not, we're able to really consolidate a lot of workloads that traditionally haven't been consolidated together. Oracle, VDI, Exchange, very, very different performance characteristics and workloads, and you typically haven't combined a lot of these together because you never knew what might happen or what you might impact if you combined all of them together. What we're allowing you to do is combine all of those together in a very predictable, easy-to-use format. And with that, that's the end of that section. Do we have any questions, guys?
I think we're good.
All right. So I have to take my drink in between sections here, so hold on one second. Now what we want to do is dig in a little bit into the VMware specific section. VMware, in case you're not familiar with it, has VMware SIOC, or Storage I/O Control. It is VMware's ability to handle storage I/O control, or really give a certain amount of fairness, if you will, between virtual machines, so that to kind of prevent the noisy neighbor in some way. The problem with it being, because they don't have any hooks into the storage, they have to make some assumptions, and they can only go so deep. And so this only addresses part of the problem. Your storage has to be very consistent. It can never fail. And it can't be used by anything else. It has to be basically dedicated to VMware. And because of that, this lack of control, what SIOC does is it basically does one of two things. It either throttles a virtual machine, it caps it, which may or may not be a good thing, or it prioritizes. So certain virtual machines get to kind of jump to the front of the line when there's contention. Again, it's a very effective way to solve it when you don't have any insight into the bigger picture, but you will still always be at the mercy of the storage subsystem. You're always making an assumption. That storage subsystem is a large black box to VMware in this environment. And that leads to what happens when something goes wrong. What happens when that black box, if you will, is in a performance degraded state? What if SIOC goes to kick in, and is that a noisy neighbor? Maybe a drive failed and you're doing a rebuild. Maybe a service processor is down and you need to trespass all your LUNs. There's many different possible performance degradation scenarios here that SIOC just has no idea how to handle or what it can do. It simply just goes, oh no, I don't have as much performance as I did, so I need to start doing a couple different things. I need to A, start capping those virtual machines, or I need to basically turn up the volume through queuing of the ones with high priorities. Well, what if I have a noisy neighbor, and that noisy neighbor is the one with high priority? Well, you've suddenly just made your problem much worse. And this again, it makes an attempt to solve the problem, but there is no insight and no coupling between the storage subsystem. And that's where we come into play. There's some things that could be, like the picture on the right there, some things that can get lost in translation sometimes, right? And SIOC doesn't have an ability to guarantee minimum IOPS, and it doesn't have a way to provide that predictable performance. And so what we actually do is we map SIOC fields in VMware to SolidFire volume, minimum, maximum, and burst values. So what we're trying to do is take SIOC values and translate them into IOPS, into bandwidth, to latency, into performance characteristics that you would normally deal with as a storage administrator. So we're trying to provide that tighter coupling between them and really provide end-to-end quality of service. And what's really nice about this is because before you had, best case you had SIOC enabled. A lot of times you didn't even have SIOC enabled. But if you had SIOC enabled, and even with ours, if you had quality of service set up on our volumes, you still had to manually track. What if you did a storage vMotion and move something? How do you adjust the volumes? How do you adjust the SIOC? Well, because of this coupling, we actually are able to make all of these adjustments automatically. So we can consolidate all of our use cases with much more confidence now. And the storage SIOC settings are enforced by the storage system now. And that leads to some really interesting new design scenarios. The one on the left is volume QoS. That is basically what it was before. Or if you're in an environment where you don't have SIOC enabled, and it is basically you set SolidFire volume level QoS and you're off. The next one is VMware Data Store QoS, effectively tiering, that noisy neighbor scenario we looked at earlier where we went performance 0, 1, 2, and 3. This is where we could set performance at the data store level and simply by doing vMotions, storage vMotions, be able to tier our virtual machines. And that allows us to really manage hundreds to thousands of virtual machines, so that managing large environments at scale without having to customize and set SIOC levels on every individual virtual machine. And lastly, you might have a virtual machine that is mission critical to the organization, very important, and you want to set SIOC on a virtual machine level. So starting on the left, we went super wide, and then in the middle we got a little more granular, and on the right we got very, very granular down to the virtual machine level, able to provide that predictable performance start to finish. And with that, I'm going to do a demo of this. Now, I have to apologize. Unfortunately, the lab environment was not available today. When we scheduled the webinar, we unfortunately scheduled on a day where we're actually moving and expanding the lab, which is good for us, but unfortunately doesn't provide a good demo. So what I'm going to actually do is our product managers did a demo of this, recorded this, and this was actually presented at a previous VMware webinar, and I'm going to talk through it as well. So this is a YouTube video, but it is this environment that we have running here today, and this is showing this environment with a couple virtual machines to illustrate these concepts. So I'm going to flip over to that now. Playing? Cool. You guys seen it? All right, very cool. I'm going to go ahead and talk you through this. So what we've done here is it's the vSphere web client everyone knows and loves with the SolidFire plugin. We're going to open up the SolidFire plugin. And you'll notice we have a SolidFire cluster up at the top. You are able to manage multiple SolidFire clusters. And then we have two data stores here. One is 500 gig, one is 600 gig. Data store A, data store B. And you'll notice there's a box over here, and it's gray currently. That means this SIOC is not currently enabled. We're going to enable it. And if you read all the fine print there, it's basically telling you what maps to what. SIOC setting shares equals minimum IOPS, and limit IOPS is set to the max. And then there's a burst factor. Burst because we can't manually label burst in SIOC. We basically give it a multiplier of maximum, so 4x of maximum, anything in the volume. And so we've enabled one data store. We're going to go ahead and enable the second data store. And just like that, our integration is complete. We're going to go back to home. We're going to go over to look at these actual data stores. Now, something else didn't really talk about before now, but is worth noting. there's a congestion threshold in SIOC for those very technical in SIOC. By default, it's 30 milliseconds. We actually cut it down to 5 milliseconds. So that is the latency on the data store that at which point SIOC starts to kick in. And we actually wanted it lower than 5 milliseconds, but 5 milliseconds was, in our testing, was the least value we could go with. And hopefully, in the next version of vSphere, we'll be able to lower that even more. But I have 6 virtual machines, 3 in A, 3 in B, so that's why they're labeled A and B. If I go look at the SIOC settings for a virtual machine, you'll notice shares equals 200, so that is my SolidFire QoS minimum of 200. And then I have limit IOPS, which is 2,000, so that is my maximum. So what I've said here for this individual, I've set it on a per VM basis. This VM has 200 minimum, 2,000 maximum, and then because of that 4x burst factor, an 8,000 burst. And what you'll notice here is if I go look at the volume QoS, this is a roll-up, it's additive of all of the virtual machines in that data store at any given time. So 3 virtual machines, all set exactly the same, 200, 2,000, 8,000. You add those all up, you're going to end up with 600, 6,000, 24,000. Now, what's interesting here is you notice we set this all up to start. Well, what if we went and moved one of these virtual machines? What if we took one of these virtual machines over here, one of these A or B virtual machines, and moved it? Prior to this integration, it wouldn't follow. We're going to make sure that this follows. And so what we've done here is we're running load on them to make sure it's actually enforcing the maximums. We've got data store A, data store B, both of them cranking at about 6,000 IOPS per. And if we move one from one to the other, prior to this integration, what would happen is we would effectively, basically, sorry, one second. Is everyone still seeing the screen okay? Okay, cool. I just want to make sure. Sorry. Basically, what would happen is you would move things around, but that quality of service would stay the same. Well, we don't want that to happen. We want it to follow the virtual machine. And so what we've done here is we've done a storage vMotion, and we're going to click over here and actually look, and you'll notice when the bandwidth severely ticks up like that, that means a storage vMotion is happening. Basically what we're doing is we're moving that virtual machine from one data store to the other right now. And again, going back to quality of service, not every I/O is necessarily weighted the same in a SolidFire system. When you do a storage vMotion, it's actually given 1/256th of a standard I/O. Because of the VMware integrations, we're able to directly talk and provide an efficiency level there so that even though we're taking a lot of bandwidth, we're still able to maintain performance on the rest of the array even while we were doing a large amount of storage vMotions. And you'll notice on data store A, the performance has gone down from 6,000 to 4,000. And data store B will, of course, increase as well. And what's really nice here is, again, the fact that I didn't change anything in a per virtual machine setting. I didn't change anything on SolidFire. And simply by doing a storage vMotion, I'm able to move things around. And I'm going to hit refresh here in a second. And when I hit refresh, you will notice that all of this picks up. And so that virtual machine that I moved is going to pick up those new data store characteristics. So I'm going to take a drink here real quick. We're going to hit refresh, and there you go. Data store B now only has 2 virtual machines. Data store A has 4 virtual machines, providing predictable performance to each virtual machine and guaranteeing and adjusting that performance on the SolidFire system. So set in VMware and enforced on SolidFire. This is the SolidFire interface. You'll notice quality of service. What we've done is, again, through those API calls and the plugin, we basically have called the SolidFire array and told it to adjust its quality of service. And so we'll go back here now, and you'll notice it is adjusting down, just like we thought it would. And you'll see data store A is adjusting up, just like we want it to. And with that, I'm actually going to click out of this and head back to the presentation. Any questions on that? If you have any questions, just go ahead and type them in chat. We're going to take just a real quick second on that to make sure that that was clear to everyone. If you have any questions at all, please let us know. And if not, we'll proceed on to the next section. Any questions you need me to reread? Okay, awesome.
Well, how do you define burst and the burst time?
So, Rob, do you want to take that one?
Sure. So you can actually set the burst level inside of SIOC. You can set, what factor of that maximum. In this case here, it was set for 4x of the maximum. You can change and adjust that to whatever you want it to set. Now, the burst level is really based upon how many IOPS below maximum you have used in the past, and we actually accrue a concept of credits that are accrued as you go below the maximum. And as you burst above the maximum, you'll actually spend those credits. The average length is about 60 seconds that you can burst at the maximum performance level or at the maximum burst level for about 60 seconds, and then we will pull you back down to that maximum after you've completed the burst. The whole reason we do that bursting is SolidFire understood early on that data is never consistent, a consistent flow, and applications need to be able to burst above and below. If you the concept of a hard drive, going as fast as it can, and you try and do a read request, you'll get timeout delays and stuff. So we identified it as being a potential problem with guaranteeing performance, so that's why we inserted the burst. Yep, and think of it this way, maybe a scenario might help too. The perfect scenario, I think, is VDI boot storms. Think of it this way, you have a bunch of VDI desktops, they're all turned off. Because they're turned off, they're not using any I/O. So they're building up a bunch of credits. You turn them all on at once, they're going to blast the system coming up. They're all trying to boot at once. Well, because they have credits, they're able to go beyond the maximum for about that 60-second or so, and then that typically gets you through the boot storm, and then you basically come back down over time to your natural performance characteristics of the VDI desktop over time. So that's a good one that a lot of VMware folks can understand and relate to. I've certainly seen that one a lot in the field. Yeah, so the question is, with more credits, are you able to burst longer? Yes, absolutely. Up to the 60 seconds. We actually have a formula based upon that. They're not like rollover minutes where you can burst forever. We'll limit that based upon the difference between min and max IOPS and where the burst level is set. Cool. All right. Going to move on to the next section. If you have any other questions, please go ahead and put them in chat. Thank you very much. Yes, 60 seconds is the max. Yes. So what we're going to do here is, that's great that we put all these applications together. That's great that we solved some of the performance characteristics of all of this. The concepts that we wanted to really talk about here was a lot of people, when they purchase storage systems, they purchase on the idea of dollars per gig. Dollars per gig, really assuming 100% utilization of the systems. but at the same time, they load a few workloads on them, especially mission-critical workloads or unpredictable workloads, and they don't get anywhere near 100% utilization. So you have this concept of a usable dollar per gig. And the lower the utilization of the array, at the end of the day, the lower the usable dollar per gig. And that is why it's not uncommon to find different storage systems wholly dedicated to single applications. Because, again, it's that way of guaranteeing performance, guaranteeing utilization. How do I put all of this together and not kill the economics of a shared environment? And that's what we're looking to do here is we want to solve this idea of forced over-provisioning. And so a couple things we do. All of our data is compressed, deduplicated, and thin provisioned. In addition to that, it's stored in two different places. It's not RAID 1 mirroring. It's actually called Helix DP, Helix Data Protection, which it's beyond the scope of this. I'm not going to go into it. But just think of it this way. If you look there, there's 30 terabytes up there, 15 terabytes raw, 15 terabytes Helix DP. And then we basically apply thin provisioning, compression, deduplication, all on the fly, all in line. So this isn't bolt-on. The architecture was built from the ground up with this in mind. And because of that, we're very comfortable with a lot of the ratios we're seeing. Of course, your workload and your results may vary. But at the end of the day, this isn't something that under heavy load, we will disable certain features to make sure we're still able to go fast. This is something, no matter what, our architecture was built from the ground up with all of these efficiencies in mind. In addition to that, snapshots and clones. Snapshots and clones really, this is what you need in today's market to really just stay in the game. And so, both snapshots and clones, of course, but what's really nice here is, again, the idea of how do I do this as efficiently as possible? Everything is deduped, everything is compressed, and that also brings into, we do replication as well. And so how do I take snapshots and clones and replicate them to another SolidFire array? Or how do I back them up to another target as well? Could be Swift, could be S3, could be another SolidFire system. So again, what I want everyone to grasp here is the idea that the architecture is well thought out, not just in how to store data, but how to manage data. How do I manage this data as efficiently as possible? Because everyone needs backup. Everyone needs replication. Everyone needs snapshots. Everyone needs clones. And so because of that, typical operational efficiency. If we just take an example out in the market, names have been sanitized. And how do you compare? Well, in this instance, we went from 44U to 5U, 89% less rack space, less power and cooling, a lot fewer cables, and an increase in performance per rack. And so what we're looking to do is increase performance, predictable, guaranteed performance, consolidated performance, at the same time consuming less power and consuming less rack space. And what we feel is a very efficient solution. And with that, I'm going to flip it over one last time for questions before I wrap it up. Thank you for your patience with the audio delay, everyone, as well. So if you have any questions, go ahead and type them into chat, please. Going once?
No, just going just a second to type.
Going twice? All right. So thank you again, everybody. Just to talk briefly about this, if you're interested in more information, solidfire.com/VMware specifically. And also, normally I wouldn't have said this, but hey, since we used the YouTube video today, SolidFire channel on YouTube is very helpful as well. It was for us. So what we talked about today is we did an introduction, the short version, SolidFire, and then we talked about consolidating multiple mission-critical applications and at the same time guaranteeing that performance end-to-end. We showed you a demonstration of that. And then we showed you how we can do all of this in an efficient manner as possible.